In this video, I'm going to talk about formal language and automata, and I'm going to discuss grammar, then sentences, then language. I'm going to keep it pretty simple, and I have made my notes so that I don't go wrong anywhere. Okay, so let's begin with grammar. Forgive me, my spellings are wrong. Okay, now according to formal language theory, a grammar, let's say G, oops, what is okay, yeah, a grammar, let's say, what's going on, some problem with the computer, I guess. Okay, for example, let's consider grammar, which is G is represented as 4 tuple, TOUPLE, tuple. Grammar G is represented as 4 tuple. It's represented something like this: G, G equal to, within brackets, V, then T, then P, then S. Okay, so this is our grammar G. Let's increase the size a bit. Let's see, it should be better maybe. Okay, so grammar is represented as VTPS. Now let's explain each of this. What's V? V is the set of variables in the language. Set of variables in the language. Okay, so V is the set of variables in the language. What is T? T is the terminal. Okay, T is the terminal. Don't ask me what terminal means in this case. I won't be able to explain this, but I'm going to show you what it means. Actually, I don't know why is the name terminal, but I'm going to show you what terminal is in a moment. Okay, V is set of variables in the language. Means, suppose in the C language, V is the number of variables. Let's say, and suppose A comma B comma C. These are our variables. Okay. For example, suppose the variables are A, then B, then C. Maybe, why not? These are our variables. And the terminal, it may be, suppose 2, then 8, then 6. Why not? It can be. Okay, this is our terminal. Then is the production rule. P equal to production rule. P is the production rule, and production rule actually tells us how to map the variables with the terminals. Okay, now let's hop to Paint, and let me show you actually. This circle here, okay, and size the biggest one, so you can see, or the second one is okay. Okay, consider 3 of these. Okay, now what are these? These are nothing but sets. Okay, use brush, blue. These are our sets. Okay, now consider this circle or this set as my V. the set of variables. And what are the variables here? I have said a, b and c. A, B, C are the variables. These are my set of variables. Okay. The next set is t. What is t? The terminals. The terminals. Okay. And what have I set in the terminals here? 286. Okay. So in the terminal set, it would be 286. Okay. This is our set of variables, and this is our set of terminals. Actually, it's difficult to find the mouse here because of this little square. It's difficult to trace. This is our set of v. This is our set v. This is set t. Now this is p. Okay, the production rule. How to map the set of elements in v with the set of elements in t. Okay. I'm using the word map and sets, but don't confuse set theory here. Okay, just for explanation's sake I'm saying this. Okay, now how to map them? It can be, production rule can be a with 2, which is equivalent to a equal to a equal to 2, which is equal to a equal to 2, and suppose b is 8. Okay, which is equivalent to p equal to 8. Okay, now how actually this is better if I do the text like this: c maps to 6, which is equivalent to c equal to 6. So this is a production rule, and if you observe carefully, I'm sure you have done variables in C, and you have written a equal to 2 in this manner: a equal to 2, b equal to 8, c equal to 6. Okay, and so this is the same thing here. Actually, the set of variables is v, and in this case it's a, b, c, and t is a set of terminals. Means what it actually is, means what actually is a, what is stored in a, 2 is stored in a. So this is the set of terminals 2, 8, 6. In our case, it's a very small set of variables and very small set of terminals. Let's say only 3. And this is a production rule. Somehow the mapping would take place. Okay, please note that the mapping may not be as simple as it's shown here. It can even be, for example, it can even be like this: a, which can be a, then b, then 8. It can even be like this. It can take any form, provided that both of them are members of either this or this, either set of variables or set of terminals, but it's possible. Okay, now let's jump back to notepad. Okay, this is our grammar. Then okay, now let's proceed. Okay, let me I should state a few points actually. Okay, yeah, s, I missed out s. What is s? S is equal to the start symbol. Start symbol means from where to begin, or where to begin the evaluation of sentence, because it's a grammar, right? It's a grammar, and from grammar it's words, then to sentence, then sentence to the language, right? from grammar to sentence and then to language. Okay, so s is a starting symbol. Okay, it will be more clear after I state an example. In a short while I'm going to state an example here. Okay, and I should mention a few properties of these actually. It is pretty intuitive, but still I'm going to say this. Brush. Well, as you can see here, the set of elements v, it cannot be empty. A language set of v cannot be empty. Set of variables in a language cannot be empty. Otherwise, it makes no sense actually. If the set of variables empty, then there's nothing. Um, there's no way of how we can make a. There's no way how we can make a sentence with no variables. Okay, and set of determinants also cannot be null. Okay, these are some properties. Then another intuitive property is, um, as you can see, this is a, b and c. This set holds a, b, c. This set holds 2, 8, 6. Means what a can store would be a subset of t, that b can store would be a subset of 8. Now if you use your logic, you can figure out that v and t cannot have common elements. It's not possible. V and t cannot have common elements. It's not possible. So v intersection t is always a null set. It's not possible to have some elements common in b and in v and t. Okay, so these are some rules. Okay, now v union t. V union t is possible. Why? Because a union we mean the common, take out the common elements from set v and take out the common elements from set t, and this is possible. We can take out the common elements from v, I'm sorry, we can take out the elements from v and t, and we can make another set. V union t would be another set, right? And we can make that set as v uh, we can make that set as the set of elements contained in v and set of elements contained in t, both. Okay, we don't need common elements. It's a union, and it is possible. And the union in this case would be a, let me write here actually, it will be better. And v union t, oops, v union t would be equal to a comma b comma c comma 2 comma 8 comma 6. This is the common elements, right? Now after making this set v union t, we can pick up 2, because 2 belongs to v union t, or we can pick up a belongs to v union t, and so on. Okay, I know it's a bit confusing, don't worry, it's just theorems, so I have to explain the theorems in this way. Just keep in mind something I should say here. If you have done the C programming language, you have probably come across some error like this, such as syntax error. Okay, like if you have done for int I equal to 0, oh sorry, for I equal to 0, I less than 5, semicolon I plus plus, and after I plus plus, if you have done a semicolon, you have probably seen an error, syntactical error. Well, what this is happening is this is an error in the grammar. Okay, it's technically, it's not syntactical error, it's grammatical error. The grammar of the language, you have committed an error there. Okay, so let's move on. Okay, let's take an example now. Let's remove all this. Mouse is slipping. Okay, g equal to, within brackets, what you saw. So v, t, p, and s. V is the set of variables, t is the terminals, p is the production rule, and s is the starting symbol. Okay, let's do an example now. V equal to, I'm going to write in okay, this is a problem. Let's see. G equal to, within brackets, I'm going to write in different lines actually. Something, something, something. Okay, yeah, something. As you can see, it's BTPS. So within this curly braces, I will write my set of variables. Within this curly braces, I will write my set of terminals. Within this curly braces, I will write my production rule. Within this curly brace, I would write my starting symbol. I have broken it in different lines. You should also, with proper indentation, it's notepad, so there's no hope of indentation. And the indent a bit like this in your copies. Okay, now I'm going to write a set of variables. In this example, let's say it's s, set of variables s, r, then u, and then a. Okay, and instead of terminals I shall write ram, then sham, then well, then sings. Okay, and the production rule I shall write s, r, u, a. Okay, this is one of my rules. And then another rule would be r maps, I'm sorry, I won't use the word maps, I'm sorry, no maps, r for ram, which is equivalent to, right here, it's equivalent to r equal to ram. Okay, in actual practice it's r equal to ram, and in this grammar format, write in this way. Okay, r ram, then u would be sinks, and a would be, sorry, a would be well. And this is my rules, this is my production, this is my production rules. And then the starting symbol is s. Okay, now it could also be r, it could also be u, it's possible, why not, but in our case it's s. So what will be the sentence will be s is, as you can see, it's RAU. So right here RAU, okay, then at each step replace one of the variables with the terminal. First let's replace r stands for ram. As you can see here, r is ram, this is replace ram here, then a, then u. After replacing, make sure you write the rule which you used. I use this rule, r for ram, just write it down. Okay, then second stage, keep ram as it is, and it's time to replace a is a variable, and the production rule, it says a is well. Okay, oops. So write well here and uh, leave u as it is, don't change it right now. And in third brackets just write the production rule which you used. Then it's time to change the third variable. Keep first two as it is, because there are no more variables in this case. No variables here, only terminals. Okay, and for u is things. Replace u with things here, and then write which replacement you used. I used u equal to things. Okay, so this is done. So this is our sentence: Ram well sings. A for well, uh, A for well, U for sings, R for Ram. But as you can see here, if you know English language, you would know this actually does not make a real sentence. What would have made a sentence is Ram sings well, but it says Ram well sings. Well, lesson 101. Please, please, please don't use your existing knowledge. Always follow the instruction that's given here, the production rule that's given here. Please follow it. In our production rule, it clearly states as you can see, states S is R U and A. I made a mistake here. I wrote R A U. Okay, let's change our production rule. R A U. Okay, suppose our production rule was RAU. Write the production rule. Whatever is given here, just copy and paste. Means in your copy you write. Okay, then as it's given here, write it. Don't worry about the grammatical meaning of the sentence. It doesn't make any changes. In our grammar, it's our example. In our grammar, Ram well sings is a valid sentence. Okay, now one thing I must tell you here: a sentence is a set of terminals only. A sentence cannot have variables. A sentence is a set of terminals only. And if your sentence has some variables, it means that you have to solve them as well. Okay, means you replace the variables with the terminals. A sentence cannot have variables. As you can see here, there are no variables here. In this line there's a variable u. Use a variable here. This line two variables. Okay, two variables, but this line has no variables. This is our final line. The final sentence cannot have any variable. So this is done. I'm going to show you something else. According to our present grammar, Ram well sings is valid. Okay, Ram well sings is valid, but Sham well sings is invalid because S is R and R is Ram. So Ram well sings is valid, but Sham well sings is invalid. Okay, now how we can modify our grammar so that Sham well sings is also a valid sentence. To do this, we must change our production rule a bit. Okay, copy this. Okay, R is Ram. Okay, this is a production rule, but if we change it a bit like this, or Sham, so R is Ram or Sham. So R can be Ram or Sham. Then Sham well sings is a valid sentence because R can take Ram or Sham. So both are valid sentences. Okay, now you can have multiple like this. Suppose S is RAU. In your language, it's your language, your code, you can do whatever you want. It can be or RA, why not RA? Then it can also be A, then U, it can also be U, then it can also be A, anything. It's your language, you can do anything. But remember one thing, if it's given in the question S is RU, you can't change it. I'm just telling you an example. I'm just giving an example of this or thing. Means S is something or something or something or something. Okay, so this is the or thing. And what this means is both are possible. Ram and Sham are for Ram and Sham, both are possible. Okay, okay. um I'm just tell something else. um I'm going to discuss. Okay, I think is there anything lambda? I need lambda. No, I need lambda. um in this tutorial I'm just going to write lambda every time. But okay, let's switch to paint then. Oops, oops, oops. Okay, instead of everything here. Okay, yes, okay, fine. Okay, lambda, this is our lambda. Okay, and lambda, it means, what lambda means is null. Lambda means null, means nothing. So if in a sentence is, if in a sentence it's R is Ram or Sham, or lambda means R can be Ram or Sham or nothing. R is nothing, it's null. Okay, it's null, nothing. This is nothing, null. Okay, this is the lambda thing. Okay, so let's learn something else. Okay, let me tell you a sentence. Let me give me the definition. According to formal language theory, sentence is a string of terminals that can be reached starting from the start symbol S by repeatedly replacing production rules from LHS to the RHS. Okay, what is language? Language is nothing but a set of sentences, a collection of sentences. Okay, as I stated earlier, grammar makes sentence, sentence makes language. Grammar makes statement, statement makes language. Grammar makes sentence, sentence makes language. And it's pretty obvious actually. If you can see here what it says. What is sentence? What is sentence? This is a sentence. Okay, according to formal language theory, sentence is a string of terminals. As I said earlier, there are no variables, it's only terminals. So sentence is a set of terminals. Okay, answer terminals that can be reached starting from the start symbol S. This set of terminals can be reached from the starting symbol S the starting symbol, that is starting symbol. The last is starting symbol. This is starting symbol. This is a production used for starting symbol. So this is our starting symbol. The sentence can be reached from the starting symbol by repeatedly replacing the production rules from left hand side to right hand side. As we have done here, we replace the production rule of R, then A, then U. Repeatedly we replace from LHS to RHS. Well, you can also replace from RHS to LHS. Same thing, doesn't make any difference. Okay. Okay. Now let's do something. Any string W, let's consider any string as W. You write any string with W. What is string? A string is sentence. Okay. Now any string W can be called as sentence if and only if W belongs to T. Okay, this is a mathematical thing I should draw because I don't know what the symbols are. Okay, W belongs to T set of terminals where starting symbol, where we can reach starting symbol, we can reach from the starting symbol to the string W. Okay, if and only if this rule is satisfied, the string W is a valid sentence. Now if T equal to A B, then T T star equal to lambda. The symbol, you write the symbol, then A, then B, then AB, then DB, then ABA, then ABAB, and so on, all possible combinations. T star is all possible combination. Now what is T star? T star is nothing but clean closure. Okay, anything with T, whatever combinations. Okay, it means any combination with the elements of T. It can be nothing, null means lambda, then only A, then B, then AB, BB, whatever combination you can think of. This is clean closure. And there is another term, that's positive closure. Let me write it down. Clean closure and positive closure. Positive closure is clean closure minus lambda, means except the null, all other combinations. Okay. Now T star, another way of saying T star means, what is T star? Is set of all possible combination of terminals. This is T star. Okay, then clean closure, positive closure, all this is okay. A language is nothing but a sentence, a group of sentences make a language. Okay, now I'm going to write it down a bit. L equal to, within braces, curly braces, W, which is the string. It belongs to a set of terminals. T star actually, clean closure. A sentence can be null also, or anything, where we can reach from starting symbol to the string via any means. Don't use the circle, it's just asterisk. It's same thing as star. From T star, this is same concept, star. Okay, close it. String, okay, let me explain a bit. A string, okay, what's wrong? A string which belongs to T star. Well, till I okay, I'll explain this. Okay. W belongs to set of terminals, the clean closure, and starting from the start symbol S, following any possible path reaching to W. Okay. Now let's do an example. Would clear our concept a bit. Till I can find a way of how I can write these type of symbols. I have to write less of this. I'm going to start with only one example here. Hopefully I can find some way to write all these symbols, then this one, then this one, then I will be able to write more. Okay. As an example, G equal to, grammar is within curly braces S, then A, B, then S is A, S, B, or A, B, close, then S. If you've been following, you should be able to guess what it is. It's set of variables, the set of terminals, production rule, then starting symbol. Okay, then let's try to solve it. S is equal to A S B. Okay, S is equal to ASB. Now, okay, S is equal to either ASB or equal to AB. Now, with ASB, it can be A, then S is again ASB, then B. Okay, now in this case also S here. Okay, and S can also be A, B. S can also be AB, right? So we can replace S with this as well, and for this S it can again be A S B, then B and A B. S can be AB or S can be ASB, right? So this is all the possible combinations, and this goes on. Actually, this will keep going on. As you can see, the language then becomes AB A B A B, comma, so on. It goes on like this. This is our language. It can be represented as, okay, let's to do it properly, curly braces and write L equal to home. Okay, L equal to, write properly, It can also be equivalent to instead of writing this long sentence written as L equal to within curly braces A to the power oops, A to the power n p to the power n, where n is greater than equal to 1. It can be written like this: a to the power n, b to the power n, where n is greater than equal to 1. So this is our language. It's pretty simple. You should practice a few examples. In the next video I shall dive into another chapter and give you examples of this. Actually, I'm pretty uncomfortable typing this in notepad because it's pretty difficult to explain in this way. I'm going to find out another way how we can write all these symbols properly. Till then, take care and do subscribe and share with your friends. Thank you.